Okay, did a little test on the Crosman 2100 with 3 pumps today. What I wanted to do is explain this sheet of paper I have for you. This is some interesting facts that you can use, and you can compare these details. Just this sheet alone could be hours and hours of conversation about different variables and stuff like that. But I just want to point out some things for you, and then you guys can take the chart and analyze it and do what you want with it. So what I'm going to do is I'm going to explain what's going on here. What we have here is we have a wad cutter pellet. These are the grain weights, and then we have round nose category right here. The first row that you're seeing, that's a muzzle velocity that I took with the chronometer, just really quick. So it's going to be plus or minus 5 feet per second. So this is in no way perfect, this chart. It's just an idea to go by. Same thing with this row, the muzzle velocity. And then this row here, you got muzzle velocity at 25 yards. That was my sample right there. With an actual chrony, this wasn't math or computer formulas. This was actually me physically putting the chrony at 25 yards and shooting over it. This here is the ballistic coefficient right here. And ballistic coefficient, basically the easiest way to explain ballistic coefficient is the ability of the pellet to keep its velocity from start. So if you had a perfect ballistic coefficient at 25 yards, it would still be 580. But in the real world, there's resistance and gravity and stuff like that. So this one's got a low BC because it's not efficient. It can't keep its velocity that it started with. So it loses velocity very quickly. And that's one of the things that people don't understand about light pellets is the fact that, yeah, they're fast, but they're fast for a very, very short time. Once you get them out in further distances, they slow down quite rapidly, as you can see right here at 50 yards. So here's the 50-yard mark for all these grain weights right here. And obviously, feet per second right here. And obviously, the round nose pellet is more efficient than the flat nose, so it's going to be more efficient. And let's see if I could do this so I can keep the whole thing on here. What you're looking at here is time to target in tenths of a second. So for instance, if you wanted to round this off, well, let's see. This one is, for instance, 4/10 of a second. If you don't want to count that little part, it's basically 4/10 of a second. So these are the readings in tenths of a second. Now, what's useful about time to target, and this was at 50 yards, by the way, the time right here. What's useful with this is knowing how fast the pellet's going to get there. For instance, if you're hunting game or something and you want to take a long shot and you know that you have some accurate pellets, but you don't know which one would be the best. And let's say that your game is moving around on you quite a bit. So when you take that shot, it's going to take the pellet some time to get there. You want to go with 4/10 of a second right here instead of the 5/10, because believe it or not, 1/10 of a second, game and stuff, when they move very, very quickly, a tenth of a second can cost you that shot. So that's something to consider. So that's lock time. That's not discussed or it's not talked about very often, but lock time is definitely important. Depending on what kind of shooting you're doing, lock time is important. So, but anyway, take this chart as it is. You can copy this stuff down or whatever, or do a screenshot on your screen. And what you could do is you could store this on your computer as 3 pumps with the Crosman 2100. This is what I can expect out of these pellets. Let me name you the pellets too, so that you know what I'm talking about. This one here these are all very good pellets, by the way. So just because they have a low BC, it doesn't mean you can have fun with them. You can do really lot of good accurate shooting with these. The first one here, this is the Predator GTO, 5.5 grain. The second one, this is a R10 pellet by RWS. This one here, the 7.56, this is a Finale Match pellet. This one here is at 8.2 grain. This is also an R10. And then this one here is the RWS Super Mag. Uh, Going down here at the round points, we got the 7.33 grain air arms. We got the air arms 8.44 grain. This one I was impressed with. This is a 8.5 H&N Sniper medium pellet. You might want to check that out. Them are pretty interesting. Got a very good ballistic coefficient. For a medium pellet having 24, that's really, really something good to see. 8.64, this was the H&N Field Target Trophy. This one here, the 10.34 grain, this was the Air Arms Heavy. So once again, if you're looking at the chart here, you've got muzzle velocity right here. You've got 25-yard velocity here, ballistic coefficient here, ballistic coefficient here, velocity at 50 yards here, and time at 50 yards, how fast it takes to get there. And the other thing too, just to give you kind of an idea of the speed that this is going, some of these pellets here. For instance, at 50 yards, 187 feet per second. That's probably 40 feet per second faster, say, like than a slingshot. So if you took a slingshot and you put like a BB or a pellet in it, that's about this speed here. It's just a little bit quicker. So just to give you an idea of the speed it's going. So anyway, there's the chart, and thank you very much for watching, and I'll try to keep you posted on some really cool details here. Thank you.